Good morning, students. Today we're going to talk about the skeletal system and why it works the way it does and how it works. So the skeletal system is comprised of bones. In the adult human, there are 206, and ligaments that work with the muscular system to help protect the body and provide support for locomotion and movement. Bone and cartilage are found at the joints, sort of like right here. And ligaments join bone to bone. So the function of the skeleton is to provide a framework for the body, just like when you're building a house, you build a frame before you finish off. It functions as support, movement. It helps to protect. Helps in the production of blood and cells, and it stores minerals and fat. One of the first bones we'll talk about is the long bone. Now I have some pictures in a book here, and I'm going to show you some long bones. So right here is a long bone. And basically it is exactly what it says. It is long. So the shaft of a long bone is called the diaphysis. It has a large medullary cavity, and the walls are composed of compact bone, meaning that it's tightly compacted. Now the expanded region at the end of the long bone is called the epiphysis. The epiphyses are composed largely of spongy bone that contains red bone marrow, and on the outside is covered with what's called a periosteum, except for the articular cartilage on its ends, where it articulates. Compact bone is made up of osteons, whose bone cells are called osteocytes. Cyte meaning cell, oste bone, so bone cells. Osteocytes are mature bone cells located within the lacunae of the bone. Now the lacunae are small pits or hollow cavities, like little lakes, where the cells are located. The matrix fills the space between the rows of the lacunae, and then canaliculi, or canaliculi, my tongue gets tied sometimes. These are the tiny canals that run through the matrix and connect the lacunae with another, one lacunae with another, and with the central canal itself. Now, osteocytes pass on nutrients and collect wastes from other cells, and they do this via the gap junctions. Spongy bone is porous bone found at the ends of the long bones. This is where red bone marrow is located. Now, the red bone marrow produces all types of blood cells. Now, the spongy bone contains thin plates, and we call these trabeculae, and they follow lines of stress, making it strong. So wherever there's a line of stress, it strengthens it. Now, the cartilage is connective tissue. Its matrix is gel-like. It contains collagenous and elastic fibers. Excuse me. Cartilage is more flexible, but not as strong compared to bone. It contains no nerves, no blood vessels, and this makes it slow to heal. Cells found in the lacunae of the cartilage are called chondrocytes. Now, there are three types of cartilage. You have hyaline cartilage that has a matrix made of collagen, and is found at the ends of the long bones and the ribs, in the nose, the larynx, and at the ends of the long bones and the ribs, and the larynx and the trachea. Um, Fibrocartilage has thick rows of collagen fibers and is able to tolerate some pressure and tension. And these are found in the disc between the vertebra and the cartilage of the knee. And you know, your vertebrae has a little cushion in between it. So they're holding up a lot of stress when we stand up and move, and our knees also. Elastic cartilage has a matrix that contains elastin fibers, and it's found in the ear flaps and the epiglottis. Fibrous connective tissue is composed of fibroblasts, which are separated by closely packed collagenous fibers and found in the tendons and the ligaments. Now, the ligaments connect bone to bone. Tendons connect muscle to bone. So, what are the bones of the axial skeleton? The axial is the portion of the skeleton that supports and protects the organs of the head, the neck, and the trunk. It's the midline of the body. It consists of the skull, the hyoid bone, the vertebral column, and the rib cage. And the skull is there to correct the cranium, protect the cranium, and facial bones. So it's a skull is the cranium and facial bones. Cranium protects the brain. It's made up of the major bones, the frontal, the parietal, the occipital, temporal, sphenoid, and ethmoid. Now, the sphenoid bone makes up the floor of the cranium, and the ethmoid helps form the orbits and the nasal septum. So, and there are also sinuses or openings that are found in the cranium. They reduce the weight of the skull and give us the ability to resonate or to use our voice. Imagine if the skull were solid, how heavy it would be. The facial bones, that's the mandible, which is your lower jaw, the only movable part of the skull. Maxilla, which is your upper jaw, and the zygomatic bones, or what we normally call cheekbones, and then you have the nasal bones. The hyoid bone is located superior to the larynx, and it anchors the tongue, and it serves as a point of attachment for muscles used in swallowing. It's the only bone in the body that does not articulate with another bone. It's not part of the skull, but it's a part of the axial skeleton. The vertebral column. The vertebral column is a series of 33 joined vertebrae which extend from the skull to the pelvis. The column supports the head, the trunk. It protects the spinal cord and nerves. It's a site for muscle attachments. Each vertebra has facets that articulate with each other and a spinous process that projects toward the back. Now, there are some issues that you might have with your back, such as scoliosis, which is an abnormal sideways curvature of the spine. It can be called kyphosis, hunchback, lordosis, swayback, or scoliosis, which just means there's a curvature. It depends on where the curvature is. If it's a hunchback, what you'll see is someone like that. Lordosis is a swayback. The back is swaying backwards. You have these vertebrae. You have the cervical, which are those in the neck. The atlas holds up the head and allows the head to tilt from side to side, and the axis allows rotation. There are 7 cervical vertebrae. Now your thoracic vertebra, you have 12. Now in the upper back, they have extra facets for rib attachments because your ribs attached to them, some of your ribs. You have then your lumbar. There are 5. They're in the lower back. You have 5 sacral vertebrae which fuse to form the sacrum. You have the coccyx or the tailbone, which is composed of 4 fused vertebrae at the base of the column itself. There are discs, which are called intervertebral discs, and they're made up of fibrocartilage. They provide a padding in between each vertebra. They prevent that grinding of bone against bone, and they're also shock absorbers. Now, these become weaker as we age, and they could herniate or even rupture. We have a rib cage. The rib cage is composed of your thoracic vertebra, the ribs and their cartilages, and the sternum, which is right here. The rib cage is part of the axial skeleton and protects the heart and lungs. You've got the ribs, which are flattened bone, and they connect to the thoracic vertebra. The upper 7 connect directly to the sternum via costal cartilage. Now, these 7 we call these true ribs. Ribs 8 through 12 are called false ribs because the costal cartilages at the end of the ribs don't connect directly with the sternum. Ribs 11 and 12 we call floating ribs because they are not attached to the sternum. The sternum we commonly call the breastplate, which lies midline of the body and protects the heart and lungs. It's made up of the manubrium, the body, and the xiphoid process. The xiphoid process is this little point right here at the end, which we have to be careful of when we're giving CPR. We don't want to break that off. And the heart is located between the 5th and 6th rib. Then we have the appendicular. The appendicular skeleton is a portion of the skeleton that consists of the pectoral and pelvic girdles and the upper and lower extremities. Now, what's in the pectoral girdle and the upper limb? Well, the body consists of a left and a right pectoral girdle, which and each side is composed of the scapula, the shoulder blade, and the clavicle or collarbone. The glenoid cavity of the scapula articulates with the head of the humerus, the upper bone of the upper extremity. Ligaments and tendons stabilize this joint. And the radius and the ulna, which are these 2 bones right here in the forearm. The hand is made up of 8 carpal bones, 5 metacarpal bones, and the phalanges of the fingers and the thumb. The pelvic girdle and lower limb, you have the pelvis, which is a bony ring formed by the sacrum, coxal bones, and the pelvic girdle. The pelvic girdle is the portion of the skeleton that consists of heavy coaxils, they're fused at the sacrum. Each coaxil is made up of the ilium, the ischium, and the pubis. All of them fused at what's called the acetabulum. The male pelvis and the female pelvis differ somewhat because the female pelvis is more flared because she has to give birth, or she gives birth, and she needs that extra room. The lower extremities are composed of the femur or the thigh bone, the tibia and fibula, which are the bones of the lower leg, the patella or knee bone. Your ankle contains 7 tarsal bones, 5 metatarsals, and these make up the arching instep of the foot. The bones of the toes are also called phalanges. We have articulations. Now, articulation is a term for bones that are joined at the joints. It's classified as fibrous, cartilaginous, or synovial. Fibrous joints are immovable, and just like the skull. Our skull is filled with joints, and they're fused together. They do not move. Cartilaginous joints are connected by hyaline cartilage, and they tend to be slightly movable. Now, synovial joints are freely movable. In a synovial joint, the fibrous joint capsule is lined with synovial membrane. It secretes a synovial fluid, which allows for lubrication of the joint. These are freely moving joints. There's fluid-filled sacs, which we call bursa. These reduce the friction between the joints, and the menisci add stability and act as shock absorbers. We have these type of movements that we can do with the synovial. We can flex and extend our feet. We can abduct, which means take away from. Adduct means to bring back towards the midline. Rotation, circumduction, which is this right here, supination, and pronation, which is standing up with the palms of your hands. Well, we all know what pronation is. That's when you're face down. Then we have inversion and eversion. The skeleton starts to form at 6 weeks in the embryo, and the bones grow in length, width throughout the adolescence, because bones are living tissues. Now, the thing you need to know is that the bones in a baby do not harden until after birth. They become hard after birth because they need to remain flexible because they have to come through the birth canal. Bones have the ability to grow, remodel themselves, undergo repair. You've got 3 types of cells involved in these processes. You have the osteoblasts, which are bone forming. Osteocytes, they are mature bones. They come from the osteoblasts. Osteoclasts are the bone absorbing cells. In other words, that's the breakdown. Throughout life, the osteoclasts are removing the matrix of a bone, and the osteoblasts are building it up. When the osteoblasts are surrounded by calcified matrix, they become the osteocytes within the lacunae. And as you know, we get older, our bones get weaker. Ossification refers to the formation of bone classified as intramembranous and endochondral. Inframembranous ossification occurs between the flat sheets of connective tissue. The endochondral ossification include these. Well, they include these steps: um, the cartilage model, the bone collar, and the primary ossification center, the medullary cavity and secondary ossification sites, and the epiphyseal growth plate. They fill in these areas of the centers of the cartilage models and have begun to break down. Um, the final size of bones. Well, when the epiphyseal plates close, there's no more growth in the bone. In women, this happens about the age of 16 and 18, and in men at about the age of 20. Hormones, which are chemical messengers that are produced by one part of the body and act on different parts of the body, such as controlling the activity of the epithelial plate. So hormones do a great deal in bone growth. Vitamin D and growth hormone will affect growth of bone. Too little hormone in childhood results in dwarfism, and adolescents experience a growth spurt due to increased sex hormones. So if you remember one year you were out of school and during the summer you shot up in growth. Bone, let's see what's mine going to talk about next. Bone repair. Repair of bone is required after a fracture or break. And this takes place over a period of several months, and it does this in 4 steps. The first thing that happens is a hematoma is formed. Fibrocartilage callus after that. Then it becomes a bony callus, and then the remodeling begins. About 6 to 8 hours after a fracture, hematoma or clot forms at the fracture site. Fibrocartilage callus fills in the break, and that's those little things reaching out to each other. A bony callus is formed by osteoblasts replacing the cartilage, and that lasts about 3 to 4 months. The osteoclasts eventually remodel the bone, building a whole new medullary cavity and creating the new bone. And you'll learn about the different types of fractures as you're studying. Blood cells are produced in the bones, as I said. Bones contain 2 types of marrow. You have yellow and you have red. Fats stored in the yellow marrow as an energy reserve, and red bone marrows where the blood cells are produced. They produce both red and white. And if you remember, the white cells we use against defense against pathogens. That is it for the bones. Our next lecture will be on the muscles. Have a good day.